developers need to do. That's going to take care of this problem. We're going to make them high assurance so that we take care of this chunk of problems. And then we're going to try and make it really easy for them to use it properly to take care of these problems. So that's sort of the goal of the project that we set out. All right, our goal really is to enable developers. What we found is that it's pretty hard to take all this knowledge in application security, and you can add the entire OWASP site to this page, if you will, and try and cram it into the developer's head. It's a lot. So I've spent pretty much my career focused on application security, and I still don't understand all of the problems that there are in application security. It's a very big space, and every single one of those problems is tricky. They're complicated to understand. So what we're going to try and do is we're going to try to enable developers with an API that does the stuff that they need to do. This is like communicating to the developers in their language, where you can use methods and parameters and stuff to talk to them. I think you also need a secure coding guideline to go along with the API. So you can't just hand them an API and say, go. You've got to give them a coding guideline that says, here's how you use this API to do the things that you need to do. And there may be some hands-on training involved to really teach them how to use it. But we think we can make this problem much simpler for developers. So let's talk about, so you might be thinking, well, I don't know, you're just one more library out there, right? Well, there's a problem with using, there's a bunch of security libraries out there, but there's some problems if you try to use those security libraries directly. So for instance, the Java cryptography extension, JCE, a lot of people use that for encryption. It's a great API, but it's what I call a bottom-up API, right? It does everything in encryption, right? It does encrypting and decrypting, but it also does a whole bunch of other stuff, like key generation and revocation and key stores and a whole bunch of things that most developers don't need. So we want to isolate all that complexity. In fact, I heard somebody call the JCE API encrypted. It's so hard to use. Right? So we want to isolate all that complexity from the developers. Most developers only need encrypt string and decrypt string. They don't need a whole bunch of super powerful, complicated crypto API. And it's the same for all these different libraries. So the libraries are overpowerful. In a lot of cases, they're also incomplete. They don't do all the things that an enterprise security developer needs to do in security. So we're trying to fill in some gaps. The fact that they're not integrated is a big problem. So you want all your security mechanisms to log stuff, right? That's how you're going to tell whether the security checks fail or don't fail. Unless all of these mechanisms use a common logging library, you're not going to get all the right output in the right place. So one thing we can do with ES-API is we can tie all this stuff together and make it log right. It's the same thing with error handling and a few other things. We want to wrap all these libraries. And that's what ES-API does. We're building on the shoulders of giants here. So I think of ES-API as a top-down API. We start with what the developers really need from a security perspective, and then we implement those methods with all this powerful stuff that exists out there. Oh, one other problem I wanted to mention is if you build your applications to these libraries, it becomes extremely difficult to change to another technology if you decide you want to, right? So if you build all your applications to Log4j or JCE directly, and then there's some problem with that, or you want to change to a different one, it's very difficult to rip all that out and replace it with a new engine. With ES-API, you get a layer, sort of an abstraction layer, that will allow you to change this stuff out. All right, so here is ES-API. You can see at the top you've got your custom web application code. It talks directly to ES-API. And then there's a bunch of different classes. This covers what we think most enterprise developers need from a security perspective. So there's authentication and a user object for identity management. There's an access controller. There's something called an access reference map that I'm going to talk about a little bit. Validation and encoding, and built in here is canonicalization. I'll talk some about that too. I've got a bunch of HTTP utilities to augment some of the weaknesses in HTTP. There's encryption and encrypted properties to store sensitive information. There's strong random number generation. Security exception handling, we've put in some support for that. We've got a logger. We've got some intrusion detection. The intrusion detector is here where we're sort of going beyond the state of the art here. And I'll talk a little bit about how this stuff works. And then all the security configuration is managed in one place. So you can actually audit it and see what changes from one release to the next. So we've tried to capture sort of the scope of what you would need in an enterprise application. And you can build that on top of your existing enterprise security services. So we know that we can't provide a one-size-fits-all library for everybody, right? You know, you're probably talking to DB2, you're talking to Oracle, other people are going to talk to their own authentication infrastructure, and so on. So what we've done is we've created this API of interfaces. There's different languages involved, but I'm going to talk about Java because that's the one that's sort of farthest along. So there's a bunch of interfaces that you can implement to, or you can use the full reference implementation that comes along with this that gives you an example of how to implement this. Okay. So you wouldn't really have to implement a lot of this stuff. Really, I think the main places where you'd have to extend this are in authentication and probably in access control a little bit, and then maybe in logging. You'd need to tie it into your logging infrastructure. But otherwise, you can probably stick with the reference implementation for things if you don't have an existing capability. OK, so let me talk through a couple examples of how ASAPI works. This is probably the best way to get your head around what's going on here. So let's talk about input validation a little bit. So I don't expect you to be able to read this, but what this is a list of of some of the different ways of encoding the less than sign that are valid in a web page in some particular context. So we've got some percent encoding, we've got HTML entity encoding, a bunch of different forms. There's JavaScript escaping, there's CSS escaping. All these different syntaxes are valid in some part of an HTML page. Over here are recipes for double encoding. There are certain ways to encode characters using two different kinds of encodings at the same time, and it really makes a combinatorial explosion. Like you could take these double encoding techniques and apply it to any of these, and you're going to result in hundreds of thousands of different possible representations of a less than sign that are valid in some particular web page. This is the problem that people have to deal with when they're validating input on the web. You have to say that input is valid in any of these possible encodings. This is a very tricky problem. Here's an example of some of the kinds of double encoding that I'm talking about. You can see over here we've got the original, which is double encoded in some way. In this case, it's percent encoding and HTML entity encoding. If you decode it first with HTML entity encoding, you get this, and then you do a URL decode and you get this, which is safe. But if you do it in the other order, if you do the URL decoding first, and then the HTML entity decoding, then you get a less than sign, which is potentially dangerous. This is an extremely difficult problem. There's a few more examples here that I won't go through, but suffice it to say that you have to canonicalize before you do input validation. Everyone always says that, but no one does it because nobody knows how to do it. So we've taken a stab at actually doing it